Hello and welcome to area of circles and sectors. So we are covering a new shape today, circles. You might have already covered this in maybe elementary geometry, which is perfectly fine. We're working with circles and let's properly define what a circle is. So I'm drawing a circle off to the right just so we could have an illustration of it. I'm going to move it over here just a little. Right here is fine. All right, so areas of circles and sectors. A circle is a point, or I should say it is a figure whose points are equidistant from its center. Center. Running out of room. Probably should have moved this down, maybe a little bit. Cool. So let's clean that up a little bit. Doesn't bother me. From its center. So if we have a center point in this circle, we could then say all of these points that land on the circle have the same distance all around. So that is your definition of a circle. Okay? Radius. So let's draw that in. A radius, hopefully you know, is a point that goes from, and let's draw straight down. Let's move this over a little bit. There you go. It is a segment. From the center point to any point on the circle. Okay? Diameter. So let's draw a separate one. Ooh, we don't need that. A diameter is a little more specific. Is a segment whose endpoints are on the circle and passes through the center. Passes through the center point. So I probably should leave more room. Let me move these down. Let's move this down first, actually. Move these down as well. There you go. Semicircle is literally just a half circle. So let's do this in green. This is a half circle. And then the central angle, let's do this in purple, is an angle formed with two radii and the center point. So here we have a central angle right here. We could call that theta. That is our angle. Okay, that is our central angle. Okay, it is literally from the center point, and hopefully that pieces together. A half circle would actually be either one of these because it goes technically through the diameter. The diameter is part of the semicircle. You could do that bottom right half of it or the top left half of it. Okay, so a lot of moving parts, a lot of new definitions for circle. Yes, it sounds, we've worked with circles before, or we are familiar with circles, but we just have formal definitions for them. So area of a circle is, you might have seen or heard this before. Area is equal to, for a circle, pi, let me get into a pen, pi times radius squared. Okay, so this is your radius, r, in your circle. This would be your diameter. Sorry, I probably should have labeled this before. and then theta is your central angle. So area is equal to pi r squared, and this is still in units squared. Measured in units squared, depending on what that unit is. All right? Sometimes we leave it in terms of pi, sometimes we don't. You'll see what we mean when we actually get some practice in. Angle of area of a sector. So if we, for instance, if we said this area, let's do a quick problem. If let's say this radius is equal to, let's say 8. What we could do here is we could actually solve this. Here's your example of this. Example is equal to, area would be equal to pi times 8 squared. 8 squared is 64, so area would be equal to 64 pi units squared. So this is what I mean by leaving it in terms of pi units. If you want the exact answer, you leave it in terms of pi. If I ask you for an approximation of what the area is, I would take 64, I'd multiply that by pi. If you don't know where pi is, it is right above, it's in blue. It is the up arrow right above the division symbol. 64 times pi is 201.0. So, 201.0 approximately units squared. All right, so there we have it. Area of a sector is literally just a fraction of a circle. So here we have it. Area is equal to, we hopefully know that the area of a circle, or the circle has 360 degrees all around. So what we do here is, since it's a fraction of the circle, we could say the angle, it is like a slice, it's like kind of like a pizza slice, right? Or a slice of pie. It is the measure of the central angle over 360 degrees times pi r squared. So here's your circle, here's your fraction of it, and we literally just take a fraction of the circle. So if, for instance, so if we want to do this problem, let's say this, we have to give a central angle to this. If I said the central angle was 60 degrees and we want to solve for that area, what we're going to do is we're going to take 60 degrees. Let's do this in purple. Area of the sector would be equal to 60 degrees all over 360 times pi times 8 squared. 60 over 360 simplifies to 1/6. Multiply this by pi, multiply this by 64, and we get our area. Doing some more simplification, 64 goes, 6 go and 64 could simplify a little bit. They both divide by 2. So you end up getting area is then equal to 6 times, cutting that in half. This would simplify to 3. This would simplify to 32. So we would get 32 pi over 3 units squared. All right, so area of a sector, area of a circle, and all these components to a circle are all now fair game. If you do have any questions, please ask. It can be a lot to take in at once, especially when we start talking about arc length and circumference. So don't be afraid to ask those questions. All right, and I'll see you in the next one. Bye.